This is Test Sketch Master. We are looking at question 3A of the just concluded May-June WAEC 2003 question, technical drawing. I'm just going to read the question and then get straight to solving the problem. The sketch in the figure shows M and N 50 apart. Point P moves such that its distance from M and N is always in the ratio 2:1. Plot the locus of P for one complete revolution. Here they say M and N are 50 apart. We can see that, and point P is such that MP is twice NP anytime P moves. So we're going to look at what we can do with that. For sure, we know that if we divide this line MN into 3 equal parts, we are going to have the ratio 2:1. So let's get that done and move on to the next step in this process. Okay, I've had this line divided into 3 equal parts already. Before we start plotting, we're going to look at the situation here. 2:1 done. The first point of the locus is going to be from here, point P. So let's determine what the other locus of this point P is going to be like. So what we're going to do is to divide to the right hand side a number of equal divisions. In this case, I'm going to choose 8. And on the left side of P to M, I'm going to have equal number of divisions. In this instance, it's going to be 8 too as well. From M here to P, okay. Oh, gotta use another highlighter. So I'm going to have from M to P, which is 2 portions. But if M is going to graduate to a number of divisions, that means I'm going to have twice this distance on the right hand side. That means I'll pitch my compass here to M, from P to M, and then transfer that distance somewhere here. And then from here, transfer the distance to a point here. So I'm going to call this place point O. So what I have here is that this point, from this point to this point, is going to be 2 times what I have from here to here. Yeah, so more like maintaining the 2:1 thing, but flipping it over. Now if you notice, you find out that we have equal divisions on the left, 1 to 8, and equal divisions on the right, 1 to 8. But because we are functioning with this ratio 2:1, this side is actually longer than M to P. M to P is shorter than P to Q. So we would start plotting. It will make a lot of sense plotting, and then we get into the nitty-gritties of why things are like that. Usually drawings are better explained practically, not in words. So I'm going to start doing that right away with M as center and with the same radius with an arc below. N as center, N as center, N happen to be at the same point as that, and 1 as radii. I'm going to cut the previous arc up and cut this one down. I'm going to continue in this progression with M again as center. The next position is 2. Create an arc above and an arc below. Again with N as center and 2 as radius. I'm going to create an arc above to cut the previous arc and an arc down here with M as center again and 3 as radii. I'll create an arc above and an arc below with N as center and radii 3. Remember, creating an arc to cut the previous arc, and this to cut the arc we created with M. That's a touch M. So right here. So I'm going to change the colors of these arcs so that we don't get confused in the end. But we'll continue this progression until we get to 8, and then plot the curve that we see with all the intersection of the arcs being this point, and this point, and the several other ones that we're going to have. Okay, with these alternating colors that I have, I believe that it's going to be clear what we're doing. The first point is what I have written out already. I'll show you that later. I have the first points here, the intersection of these two arcs with M as center and N as center, and 1 as radii. We have that point. I have another point here. I have another point here. Another point here. Another point here. Another circle. So joining all of these points, starting from P naught here, joining all of this point in proper sequence, we are going to have a result of what the locus actually defines. So let's go right at it and do just justice to that. Use your curve set or your flexible curve. Start from point P naught, going to P1. You can take any direction though, either ways would work. Going to P2, P3, P4, P5, point P6, connecting all of these points in proper sequence. The intersection of those arcs in proper sequence generated by the curve that we have. Because you're going to have a circle for one complete revolution. So this is what your drawing is going to look like. So let's go back to the question again and see if we have done justice to it. The question says the sketch in the figure below. This figure below shows M and N 50 apart. Point P moves such that its distance from M and N is always in the ratio 2:1. Plot the locus of P for one complete revolution. So this is the table we used. You may want to copy that to use that for your own drawing. You can pause the video and copy it and relate it with all the points that we have here. You find out that what you're going to get is a circle. So thank you very much for watching. Keep sketching, keep drawing. I'll see you again in another video.